Hello everyone, I am A.B.M.Salman Rahman from Changsun National University, Suncheon, South Korea, Department of Information and Communication Technology, and I am Master Integrated Doctoral Fellow. As everyone knows, energy is the most important factor in our daily life. We are not able to consider one single steps without energy. So we have to be very careful about use or utilize our energy. We have to use energy in a systematic way. There are different types of energy like mechanical energy, electrical energy, nuclear energy, light radiant energy, chemical energy, heat energy, movement energy, and so on. Today, I am going to present steel factory energy consumption prediction based on production.
About energy has been obtained as one of the key inputs for a country's economic growth and also for social development as well. Analysis and modeling of industrial energy are currently a time insertion process because of more and more energy is consumed for economic growth in an industrial factory. Industrial energy consumption analysis and prediction play a very important role in improving energy utilization rates to make a profitable things for industrial companies or factories. The main objective of this study is to present and analyze the predictive models of the data-driven system for the uses of appliance. The paper addresses the filtering of data to use non-predictive parameters and rating of features. With repeated cross-validation, 3 statistical models were trained and tested in a test set, and the 3 models are General Linear Regression Model, in short from GLM, Support Vector Machine with Radial Kernel, in short from SVM-RVF, and Boosting Tree, in short from BT. The performance of prediction models are measured by R-square value, root mean squared error, in short from RMSE, mean absolute error, in short from MAE, and coefficient of variation, in short from CV. Introduction. Energy has been seen as one of the key inputs for a country's economic growth and social development, and nowadays more and more energy is being used for both economic growth and population growth. Facilities of industrial customers and the uses of electricity to process various types of machinery, manufacture or assemble products, including such as diverse industries as production, mining, and construction. The most important thing is more than 1/3 of electrical energy is used by those industrial sectors from total energy of a country. In this slide we are going to tell about South Korean industrial history. Since from 1990, South Korea's manufacturing industry has continued to expand at a high pace and has become the main driving force of South Korean economics with rapid growth. Primary energy consumption rose at an annualized rate of 7.5% in the 1990s, which in the same period was higher than the annualized economic growth rate of 6.5%. The energy use of the industries is influenced by many unpredictable factors such as industrial structure, technology level, oil price, economic size, and also the national policy. Improving energy efficiency is very important for economic growth. To improve an industrial factory's energy utilization, this is the high time to work with Managemental Board of Industrial Factories as a technological supportive hand to improve their energy utilization. Our work is focused on energy consumption based on the productions of the Daewoo Steel Factory in South Korea. Contents. Rest of the presentations we make in 5 parts. First one, methodology. Second one, data description. Third one, experimentary analysis. Fourth one, result and discussion. And the last is conclusion. In conclusion, we will conclude our all work. In methodology. Linear regression model. Linear regression model is associated with the nursing method for analyzing the relationship between a scalar dependent quantity variable y and one or more independent quantity variable x denoted. In statistics, the general linear regression model GLM is a flexible generalization of the simple linear regression model and assumes that the data points are distributed randomly. Here our assumed model for our next work of G. Here GM is the identified relationship function, beta naught is the regression coefficient, x, j is the predictor, y is the output, O is the offset variable, and k is the distribution model of y. Support vector regression. In data science, the area unit supports vector machines and supervised learning models with related learning algorithms analyzing information. Support vector machines can also be used as a regression tool, holding all the most options characterizing the formula. Support vector regression SVR uses a similar concept for classification due to SVM with only a few minor variations. First, since the output is real number, predicting the information and hand becomes very complicated, which has infinity possibilities. And this is the equation for support vector regression. Dataset description. There are two types of datasets available in this study that have been gained from Daewoo Steel Factory, South Korea. Between these two datasets, one is the dataset for the energy consumption of the steel factory and the other is dataset for the production of steel factory. This factory manufactured different types of steel, rods and plates. The period of collecting data is 365 days, 12 months for the year 2017. In this study, data set to have the total of 18,222 entries with 12 variables. The final dataset is divided in two parts, one training validation part and another one is testing validation part by using C-caret data partition. For training, the models has 75% data is used and rest data is used for testing purpose. Energy consumption measurement for the year 2017. This plot shows the total uses of energy for the year 2017. From the plot, we can easily see the everyday uses of electric energy for Daewoo Steel Factory. Hourly uses of energy measurement for every month of the year 2017. The plot shows for total uses of energy for working days consumption of every month in the year 2017. In this figure, the x-axis shows the time in hours and the y-axis shows for total uses of energy in kilowatt. From the figure we can see that every month from morning 8 am to 10 pm energy consumption is so high, and we can also see the after 11 pm to till 8 am energy consumption is low. Based on figure, we can easily say that the Deo steel factory working hours from 8 am to 10 pm, but sometimes they work till 11. Relationship between the consumption of industrial resource with the production. From this plot, we can easily find out the relationship between electrical energy and the products of Deo steel factory. Plot shows the positive correlation between energy and scale is 0.61. This means for manufacturing scale, this Deo steel factory used more energy than other manufacturing products in the year 2017. The relation between sheet and uses energy is 0.51, and also the relation between Seong and uses of energy is 0.37. And from this correlation value shows the relationship among all manufacturing products with total uses of energy in the Deo steel factory. Component importance and preference from Boruta algorithms. This plot shows the variable importance of Deo steel factory by using Boruta's algorithm. From plot, we can easily find out that the scale is the most important variable for the Deo steel factory, and then Seong, and after that sheet is the important products from Deo steel factory. Result and discussion. To figure out the optimum controller parameters in each of the regression algorithms, it is necessary to define and minimize the error values. In our study, we use 3 statistical models to find out the best prediction model among these 3. 3 statistical models are the general linear regression model, support vector machine radial, and boosting trees. And we find out the performance of all prediction models by measuring R square value, root mean square error value, mean absolute error value, and confidence of variations percentage value. Result for appeasement values of sigma and cost for the A.B.M. radial model using grid search function. Grid search function helps us to look through predefined and fit our model for training set. Our plot shows for the grid search result for optimal values for A.B.M. radial kernel. For A.B.M. radial kernel model, we need 2 tuning parameters, namely sigma and cost. Every model has 30 outcomes for 10-fold cross-validation and 3 repeats after training of each regression model.
Results of appeasement values for the boosting trees model using grid search function. Figure shows for grid search result for boosting trees. Boosting tree model has 30 outcomes from 10-fold cross-validation sets and 3 repeaters after training of boosting tree regression model. For cross-validation, boosting tree has maximum tree depth is 1, 2, and 3.
Model performance for training and testing datasets. From table, we can easily find out the best prediction model among 3 statistical models. From table, in training part, the R-square value of general linear regression model is 0.79. Support vector regression model based radial kernel is 0.86, and for boosting tree it's 0.84. On the other hand, in testing dataset, 0.76 for general linear regression R square value, 0.85 for support vector regression model, and 0.84 for boosting trees. After seeing all R square value and all results, we can easily say that support vector regression model is better than other two models for Deo steel factory energy consumption prediction. Variable importance for linear regression, SVM and boosting trees. Plot shows for variable importance of general linear regression, support vector machine radial and boosting trees model. From plot we can easily justify that scale is the most important parameter or product for using energy in the Daewoo Steel Factory, South Korea.
Conclusion. In the case of all prediction models in experimental analysis and data analysis revealed a thought-provoking results. The pairwise plots displayed above different types of parameter relationship which could be consulted in the initial statistical models. The general linear regression model, support vector machine based on radial, and boosting trees models boost the predictions of R square value, root mean square error, and mean absolute error to compare with the models and consider from all three models. SVM radial based model give the best result for predictions. For all regression models, scale has considered as the most important product in Daewoo Steel Factory, and also for predicting energy consumption, scale is the most important factor. That's all from me. Thank you very much for watching my presentation slide, and stay with me.